Good morning, students.
Good morning, ma'am.
Yeah, good morning.
Good morning, ma'am.
Good morning. Can you all see my screen?
Yes, ma'am.
Yeah. So let me give you a quick recap on what we did in the last class before we go and continue with today's topics. It's 4th September. Right. So the last class we were trying to see what is, I'm going to give you or rather revise this topic once again because last class couple of you had some doubts. That's why I'll again explain this with some examples so that your understanding becomes better. Okay. So we have seen in the last class a concurrency control based on timestamp ordering. Okay, in this case, here we saw what is a timestamp, and then we also saw what do we mean by a timestamp ordering algorithm. These are the two things that we have discussed, we were discussing in the last class. So, what did I say? How did I define a timestamp? We also went into timestamp ordering algorithm. I told there are three basic algorithms under this basic timestamp ordering, strict timestamp ordering, and the Thomas's right rule. Thomas right rule. These are the three algorithms that we will be learning under timestamp ordering algorithm. Okay, just to revise what we did in the last class once again, I'm trying to define once again. Anyone who can tell what is a timestamp based on what we did in the last class? What is a timestamp? How did we define it? So when I say timestamp, timestamp is nothing but a unique identifier created by the DBMS in order to, it is an identifier in order to identify a particular transaction. Right? A unique identifier in order to identify a transaction is what you call it as a timestamp. Right? Why are we giving timestamp? They are assigned in the order in which the transactions are submitted. Whichever transaction comes first, you're going to assign the timestamp based on that particular order. So we can also call this timestamp as transaction start time. We can also call it as the transaction start. The moment the transaction is given to the system, you are going to assign a timestamp value to that particular transaction. So whatever value is assigned in that order only, the transactions have to be executed. All right, and we always say a timestamp of a transaction is always determined as TS of T. And I told you one more thing. How can we implement this concept of timestamp? How are this timestamp generated? There are two possible ways in which the timestamp concept can be implemented, or you can try to generate the timestamp. One is called by using the counter. This counter is going to get incremented every time a transaction enters into your system, or every time a transaction comes into the system, you are going to assign a timestamp value in the form of a counter value. So this counter value, every time you assign it to a transaction, it is going to get incremented. Right? So that means first transaction you are giving, let us say number 1, then it gets incremented to 2. The third transaction will get the number 3, like that. The other way of doing it is to assign the system date and time. System date and time is another way of assigning a timestamp. But we should see that no two transactions are entering the system at the same second of the clock or same tick of the clock. right? This is what I told you. I thought let me give it with more examples, or rather a little more examples, so that we can understand it better. So let us say, let me take example of three transactions. I have transaction T1, okay, which comes at the time 10 o'clock, let us say. Then I have the transaction T2, which comes at 10:10. It enters the system. Then we have the transaction T3, which enters the system at 10:15. So now there are three transactions which has entered the system. I have to execute the transaction in the same order. That means first T1 only has to be executed. Second, the transaction T2 gets executed. Third, the transaction T3 gets executed. What is the timestamp? Let us say I'll give the timestamp 100 to this T1. For T2, T2 has come into the system at 10:10. It has come after T1. Right? So I will give, let us say I'll give the timestamp 200. I can give 101, 102, anything after 100 I can assign, no problem. It need not be 200. I can give 1, 2, 3, 4, 5, 6 like that. I can give 100, 101, 102, 103. I can go on giving like that. I can give 100, 200, 300, something like that. Anything I can give, but it should be after 100. If I give T1 timestamp is 100, for T2 which has come at 10:10, I cannot give 90. Right? Then here for T3, let us say I am giving 300. These are the timestamps. Now this is considered to be the older transaction T1. T2 is considered to be a slightly younger. It is younger than T1 because it has come at 10:10 only, and it has a timestamp which is greater than timestamp of T1. This T3 will be our youngest transaction because it has come at 10:15 and it is assigned the largest timestamp value. Any doubts till here? I'm just trying to give more, make it more elaborate as to what we did in the last class. Any doubts at this point of time? Any questions? And when we talk about transactions, there are three different times that we define with respect to transaction. Three timings or times which we define with respect to transaction. The first one is, we call it as the timestamp of the transaction Ti. So when I say timestamp of Ti, so that means, let's say take an example. Timestamp of T1 is what? 100. When I take timestamp of T2, which is nothing but 200. Timestamp of T3, which is nothing but 300. This is one time that we will be defining. What is the timestamp of that particular transaction? So we have three transactions entering here. T1 is the older transaction. T2 is slightly younger. T3 is the youngest transaction. So TS of Ti means what? We are trying to specify the timestamp of that particular transaction. Ti, I can take any value. So when I say T1, TS of T1, it is 100. TS of my second transaction T2 is 200. Timestamp of my third transaction is 300. Okay. Now, the second time that we are going to define is read transaction or read timestamp of X or A or any data item X. Read timestamp of X, or I'll call it as RTS of X. RTS of X or A or B, whatever data item you are trying to take at this point of time. Read timestamp, or we call it as RTS. How do we define this? So last class, this was some confusion, some doubts students had. That's the reason I'm doing it with an example. So what is, let us say I have three transactions. T1, I have T2, I have T3. Suppose I say timestamp of T1 is 10, timestamp of T2 is 20, timestamp of T3 is 30. Okay. Suppose I am giving here R of A. Okay. Then read R of A means it is reading the data item A. Now at this point I will give read of A at that point. That means after T1 is reading A, T2 wants to read A. Then we give at this point. T3 is reading after T2. Now, what we are, what we assume here, one of the assumption here is whichever transaction comes first will also be the one which will complete first. That is an assumption by default we are trying to take. Whichever transaction is coming first, T1 has come first. So we assume T1 will complete its transaction first. T2 will complete next. T3 will complete last. This is the assumption on which we will be working the timestamps. Okay. Now we are trying to define here what is RTS or read time of phase or read time of E. Read timestamp of E. So I have taken this example here. These are all the timestamps. Timestamp of T1 is 10, timestamp of T2 is 20, timestamp of T3 is 30. Okay, what I have shown here, T1 reads A at this first. First it is asking for read of A. After T1 has read the data item A, okay, T2 is going to read the data item A. Somewhere later, T3 is trying to read the data item A. All are reading the same data item. Now, how do you define? So, T1 reads first. After that, T2 reads. After that, T3 reads. T3 reads last. So, read TS of A, because we are reading E, is nothing but, anybody? What will you get here? What will be the value of read TS of A or RTS of A? Anyone?
30.
Very good. This will be 30. Whichever transaction reads last, the timestamp of that transaction will be the read timestamp of that A or that data item A. Whichever transaction reads last. Read TS, I'll put it as RTS. RTS of A is nothing but TS of T3. That is equal to 30. So in the last class, we were telling read transaction of timestamp of A is nothing but timestamp of T. We were telling this. So that is how here with this example, I'm trying to show you how we can arrive at this point. Okay. So whichever transaction reads the data item last, that will be the transaction. That timestamp will be assigned to read the timestamp of E. Any doubts, anyone, at this point of time? Any doubts? Is it clear? Now, the third time that we are defining here is write timestamp of E. Write timestamp of A or X or whatever A. So I call it as WTS of A. So there are three WTS or write timestamp of A is similar to your RTS or read timestamp, except that you do a write operation. There we are doing a read operation, here we do a write operation. Let us take an example again. So I have, let us say, 3 transactions. Okay, again, timestamp of T1 is 10, timestamp of T2 is 20, timestamp of T3 is 30. Now here, T1 issues a write operation, W of A. T3 reads next. T2 reads sometime later. Okay. Now, can you tell me what will be WTS of A? Anyone? Can you tell me what is WTS of A?
10,
Huh?
10,
No. Anyone? How 10? See what is happening here. T1 is first writing A. Correct? Then T3 writes A. Then only T2 writes. T3 writes here. Then only T2 writes. Whichever transaction writes last, that will be the transaction timestamp which will be assigned to WTS. So this WTS of A will be nothing but 20. Okay. So with respect to timestamp, I said timestamp is a unique identifier which is assigned to every transaction. Why you are doing that? In order to maintain the order of the transactions in which they have to be executed. So whichever, and we always work under the assumption, whichever transaction comes in first will be the first one to complete also. Right? And then we said we can generate it, implement it using two different types. One is using the counter, another one is using the system generated time and date. These are the two ways in which you can try to implement the timestamps. Next, what we saw, we said that timestamps. There are three different times which are associated with timestamps. One, you call it any timestamp of any transaction is denoted by TS of T. And then we have read timestamp of any data item. And then we have write timestamp of that particular data item. These are the three different times. Okay, read timestamp of TS, that let me put it as RTS for short. Okay, RTS of A is nothing but TS of TI. Whichever transaction read that item last, timestamp of that transaction will be your RTS value. That's why I said in the last class, RTS is nothing but the largest timestamp of the transaction that has successfully read X. So X, this TI is nothing but your youngest transaction. This value or timestamp will be your largest timestamps. That is what we saw previously. 30 is the largest timestamp which is assigned to TS of read RTS of A. Maximum value will be assigned to that. TS of 3, timestamp of T3 is assigned to RTS of A. So TS of T3 is the youngest transaction. Why T3? Because it came last. Right? So that is how it is. Similarly, with respect to write TS, write timestamp of A will be nothing but again TS of T. Whichever transaction writes it last, that value timestamp value will be assigned. So this is nothing but the maximum timestamp that is assigned. This TI is nothing but the youngest transaction that has done the operation successfully. It could be a read operation, it could be a write operation. This much is about our concept of timestamps. Any doubts still here? Any doubts? Any questions?
No, ma'am.
Any doubts at this point of time? No. Now we will go to the rules. So when I say rules, we will go to the first algorithm, that is basic timestamp ordering. basic timestamp ordering. So what are the rules that we are going to learn under this? I'll put down the rules and then I will tell you. Okay. I'll take the next sheet. So what are the rules under the first basic timestamp algorithm? Right? The first is what happens, the transaction Ti. It can see now that any transaction which comes, it can issue either a read operation or it can issue a write operation. Let us say it issues a read of a operation. So what will happen here? You have to make sure that the order of the transactions is not violated. That means you take it up in the same order as they entered the system. T1 entered first means T1 only should be executed first. T2 enters first, T2 only should be executed first. Like that, you should take care of the order. So we have to check here. What are we going to check? If the write timestamp of A is going to be greater than TS of Ti, then roll back Ti. Okay. Otherwise, what will happen? Execute. Otherwise, it is not an issue. So you can execute R of A operation. I will show you the example here. And then I have this step is important. Set RTS of A is equal to maximum of RTS of A comma TS of Ti. That is when you are issuing the read operation. A transaction can also issue a write operation. Here it is issuing a read of A. Here it is issuing a write operation. So in this case, what you have to check, if this RTS of A is going to be greater than TS of Ti, then roll back Ti. If WTS of A is greater than TS of Ti, okay, then roll back Ti. I will show you example for this so that this becomes clear to you. If both these conditions are not satisfied, then we can go ahead with execution of write of A operation. And then the most important step is to set up this WTS of A is equal to TS of Ti. Okay, let us take some examples. This is our basic timestamp ordering algorithm. You will have to remember these steps, but once you understand it with examples, this will become very clear. So last class, I did not give you example. That's why I thought, let me do it again. Okay, now let us take two examples. Let us take two transactions, T1 and T2. This is, let us say, timestamp is 100. This timestamp is 200. Okay, this is the old transaction. Obviously, this is a younger transaction. Now, suppose T1 issues a read operation here. T1 has issued a read operation. After some time, somewhere, T2 issues a write operation. Is this transaction allowed? Anyone? Is this transaction allowed? Anyone? See, whenever the younger transaction, which is the younger transaction here? T2. Whenever the younger transaction performs last, because older transaction is R of A, it is performing faster. See the time, this is your time. Okay. After that, somewhere only W of A is coming. So this younger transaction, which is T2, this will be performing the write operation last. That's the last operation because once first T1 will perform R of A. After that only T2 is performing W of A. So this can be allowed. This particular transaction or sequence of transaction can be allowed. There is no problem here. There is no conflict here. Let me take one more example. This is T1, this is T2. Okay, again I will take 100, timestamp of T2 is 200. Suppose, let us say, T1 issues right of A, first term. Then later at some point of time, T2 is doing W of A. Is this allowed? Is this allowed? Come on, answer no. You people are listening or shall I mark all of you absent? Hardly 35 of them. Only 35 of them I have marked attendance already. Okay, rest will not get. I'll mark rest absent. I've already noted down. Don't worry. Yeah, tell me, is this transaction allowed or not? Anyone? Tell me.
No, no.
No? Why?
And because read operation hasn't been performed.
Read operation?
It's not there.
See, read operation is not there. That doesn't matter here. When we say, okay, what happened? Yeah. See here, right of A and right of A. As long as the younger transaction performs last, this particular set of operation is allowed. There is no conflict in doing this operation. Here also what is happening? Older transaction, which is an older transaction? T1 is the older transaction. That is performing a read operation on E. Okay. After that, the younger transaction performs a write on E. Younger transaction performs the last operation. As long as the younger transaction performs the last operation, the sequence of operations can be allowed. There is no problem in this. Similarly, in our second example here, what is happening? T1 is an older transaction with a timestamp of T100, right? It performs the write operation first. Now, after this write operation, somewhere down the line, T2 wants to perform a write operation. So this is also allowed. Which is a younger transaction here? T2 is the younger transaction. T2 is doing the T2 is doing the operation last. So that is why it is allowed. Let me take one more example. So T1, T2. Okay, 100, 200. Now, I will give here write of A. Let me take one more example. Sorry, this is not there. Okay, I will give here W of A and then somewhere here I will give write of A. Is this allowed? Is this allowed?
No.
Yes or no?
No, ma'am.
Why? Why it is not allowed?
Because the read operation is coming last. It should always be right.
Not necessary.
Ma'am, it can be allowed.
Why it can't be allowed?
Ma'am, T2 is having the last, ma'am, but it allows, ma'am. Rid of it allows, ma'am. Newly transacted, ma'am.
See here in this case, right of operation, I have always been telling you the youngest operation, as long as it is performing the last operation, it is okay to be allowed. Here, T1 is performing the write operation first. Somewhere after that only T2 is performing read on the A. T2 is an youngest transaction. So most recent, most updated it is. So that T2 is performing the read operation in the end. That's okay to be allowed. It is not wrong. In all these three cases, we have taken three cases here. 1, 2, and 3. In all these three cases, the younger transaction is performing last. So it's okay to be allowed. Let us take another example. Let us say T1 and T2. 100 is a timestamp of T1. T2 is 200 is a timestamp. We have here first read of A is performed by T2. Okay, then somewhere after that, W of A asks for write. Is this allowed?
No, ma'am.
Why?
Because the youngest operation is first
Yeah,
putting.
you are doing a read operation here. You are doing a read operation at this point of time. Look at this condition. This condition is what we are doing here. If RTS of A is greater than stamp of TI, then roll back it. What is read time stamp of A? It is 200 because that's the largest timestamp. If this is greater than timestamp of TI, because transaction TI has issued a write operation. What is the timestamp of this? 100. So this 200 is greater than 100, this condition. That is why you will have to roll back this particular transaction. You cannot allow this to happen. Because I told that whichever transaction starts first will also complete first. Suppose this completes off. T1 is started first, no? So it will complete first. It will write some, let us say R of A is 20. R of A reads the value, T2 reads the value of A as 20. Okay. T1 writes it as 30. Let us assume. And it will go and commit and finish it off because it has started first. What happens to this T2? Somewhere, let us say, it will go and it will fail. It will abort, let us say. Then what will happen? Whatever it has read is also wrong, no? Even if it successfully completes, whatever T2 has read is wrong. So that is why you should not allow this operation to happen. If RTS of A is greater than TS of TI, then you should roll back TI. Right? Here, if I take one more example, T1, T2. This is 100, this is 200. Now I'll first do here a write operation and then here I will do a write operation by T1. What happens here? Is this allowed? Is this allowed? This example?
No, ma'am, it's not allowed.
It's not allowed. It's not allowed because if you see here, T1 has issued a write operation again. You have to check. This write is already done. Timestamp of A is what? 200. RTS of A is what? 200. Which is a transaction which is asking for a write now? T1. What is the timestamp of that? 100. 200, sorry. Yeah, 200 is greater than 100. What we should do? We should roll back TI. Again, this will be rolled back. And then you will have to start the operation again. Is it clear? This is our basic timestamp ordering algorithm. Right? Any doubts, anyone? Any doubts? God, yeah. Any doubts, anyone?
No, ma'am.
Next, we move to the next variation of that, which is called as the Thomas Wright rule. Okay, what happens in this case? This is actually a modification of our basic table. What was the message here? Somebody messaged me. Not allowing the transaction, these are the only two scenarios that I can give you. Either you do a write operation, you do a read operation, and then you are asking for a write. Two cases we have shown. These are the two cases for which you have to roll back the transaction. And remember one thing, whenever the younger transaction is performing last, you can allow it. If the older transaction is going to perform last, then you cannot allow, you have to roll back. That is a simple funda that you will have to remember. Okay. Next, let us come to the Thomas Wright rule. This Thomas Wright rule, observe here. It is a Wright rule. That means you are going to change only the writing operation of your basic TO. These are our steps in our rules in the basic TO. Okay, what happens to the right is what we have to see, Thomas Wright rule. Okay. Now, what exactly happens in our basic timestamp ordering algorithm? Let us see that again. Now, let me put down so that it becomes easy for you to understand. Let us say transaction T1. Okay. We are only bothered of write here, not read. That's why it is called as write rule. What happened in our basic timestamp ordering algorithm? If this transaction T1 issues a write, okay, I'll put on the same steps what we did in case of basic algorithm. If your read TS of X is going to be greater than TS of TI, okay, or your write TS of X is going to be greater than TS of Ti, what are we going to do? We are simply going to abort that T, right? And we are going to roll back. This is what we did in our, just now we did in our basic timestamp algorithm. Else, what we'll do, if this condition is not satisfied, we'll simply go ahead with writing of that X. That means it is allowed. Write operation is allowed. And then we will set write TS of X is equal to TS of T. This much we are doing. This is our basic algorithm. How different is our Thomas Wright rule in this case? Thomas Wright rule is an improvement on the Wright rule compared to your basic. This is our basic. So far what we have seen is this only. Basic TO algorithm. What is Thomas Wright rule now? Let us try to modify it. Thus, what we are going to write now is the Thomas Wright rule. Okay. Now, read, we have no issues. If read TS of X is going to be greater than TS of T, then we will simply abort and roll back. So there is no change in that. Okay. Now, here we said for write also, we told the same thing. This write is what is going to get changed, or it is going to get modified in our Thomas Wright rule. What will happen here? That's why I'm writing it separately. If our write TS of X is going to be greater than this TS of Ti, we'll ignore the write. That's all. We are not going to abort. We'll ignore this write, but continue the transaction. That is the only difference between basic TO and our Thomas Wright rule. That's all. Here what we did, if read TS of X is greater than TS of Ti, we are going to abort and roll back. If write TS of Tx is greater than, that means either a read operation or a write operation. If this condition is satisfied, then we are going to read and abort and roll back. Else, if this condition is not satisfied, we simply go ahead with the write operation. That means we are allowing the operation to do. We saw examples of that previously now. What is the difference between this and this is our basic timestamp algorithm. What is the difference between this and our Thomas Wright rule? As I told you, Thomas Wright rule is an improvement on the Wright rule compared to your basic TO algorithm. What is the improvement that you are making? If the read operation, when you check for this condition, there is no change in the read operation. You will simply abort and you will have to roll back. But for the write condition, if this condition is satisfied, we are not going to abort the transaction. We'll ignore the write. That means we are not going to perform this write, but we'll continue with the transaction. We are not going to abort it. Let's take an example. Okay, let us say I have T1, T2, T3, T4. All right. Now, timestamp is 1, 2, 3, and 4. Just for sake of discussion. All right. Now, suppose I have this data item X to be read and written. I will say RTS of X is 3, WTS of X is also 3. Now I will have two transactions which are coming in. T1 wants to do a write operation. T2 also wants to do a write operation. This is fine. First T1 will do and then T2 does. There is no issue here in this case. It will come in this part where the condition is not satisfied. So you allow the write to happen. After this, suppose you have another write here. Okay. In our normal case, what will happen? Normal TO algorithm, we will abort this and then we'll roll back. But in case of Thomas Wright rule, this will be ignored. This write we are going to ignore, but still we will continue with the transaction. We will continue with the transaction. We are not aborting the transaction otherwise and restarting the transaction. If the first case, basic TO algorithm, if this appears, if this case appears, we will simply roll back because you are having a write operation at this point of time. Till here, no issues. When this write comes, basic algorithm, you will abort and roll back. If it is a Thomas Wright rule, you will simply ignore this write. And you will continue with the transaction. Whatever next is there, you will go ahead with that. That is what is called as your Thomas Wright rule. Any doubts? Any doubt, anyone?
No, ma'am.
Good. All right, that is about Thomas Wright rule. Next, we will move on to. We have what is called. Oh, sorry. I have to change this. We have what is called the multi-version concurrency control technique. We will move on to the next concept, which is multi-version concurrency control technique. Now, in case of timestamp ordering algorithm, we saw three cases. One is basic, one is Thomas Wright rule, and another is strict. In that strict, I didn't give much importance to that because in the strict, either you are getting, if you get a read or a write operation, the strict version of your TO, the read or the write operation by the next transaction will be slightly delayed. That means until one transaction finishes off, commits, the other one will not start. That is why you call it as strict. Okay. So there are three different algorithms: basic timestamp ordering, strict timestamp ordering, and then we have the Thomas Wright rule. Right. Next, we are moving to multi-version concurrency control operation. Now, what do we mean by multi-version technique? Now, in this case, in case of multi-version, as the name only indicates, old values of a data item. Okay, old values of a data item will be retained when the item is updated. Suppose I have X. There will be so many versions, old values of this X, X1, X2, X3, X4, X5. This is my recent value, most updated value. But all these values will also be retained. That is why you call it as multi-version concurrency control. Several versions of the or several values of an item will be maintained. So whenever a transaction requires a particular item, okay, suppose I am accessing this X now. Which version or which value of X is appropriate, most appropriate, that will be given to the transaction. Okay, so that means the older version of the item is always maintained when you still want to write a newer version. That is what we say multi-version technique of the concurrency control. So in this method, you will have several versions of this data item X which are maintained. For each version, the value of the version and 2 timestamps are maintained. As I said, X is my data item. What are the different versions of X? X1, X2, X3, X4, X5. These are all the different versions of X. Versions means what? The different data items that the different values that this X has taken. These are all my old values. This is my most recent value. I will maintain everything in the database. That is why you call it as multi-version control or multi-version technique. Now, for each version, what are you maintaining? We are going to maintain the value of each version and 2 timestamps we are going to keep. 2 timestamps for each of the version. First one is what? Again, we come to read TS. For every version, we are going to maintain these 3 things. What is that? One is the value, 2 timestamps, one is read TS and the write TS. These 3 values we are going to maintain for every version of the data item. So for X1, I'll have the value and 2 timestamps. X2, I'll have the value and 2 timestamps. X3, I'll have the value and the 2 timestamps. Like that. Read TS means what? Again, read timestamp is nothing but the largest of all the timestamps that have successfully read the that particular version. Same concept of or the meaning of RTS holds here also. Write TS is also the same thing, except that you are doing a write operation. Write timestamp is the timestamp of the transaction that wrote the value of this version. Okay. Any doubts? Is it clear? What do we mean by multi-version concurrency control technique? Now, whenever a transaction is allowed to execute, let us say a transaction comes in, T1 or TI. Okay, suppose suppose this transaction is allowed to do a write item of X. That means it wants to do a write operation on the data item X. So then what will happen? You are going to create a new version of X. Right? You are going to create a new version of X. And then what we do? We have 2 timestamps. So new version of X means this will have a new value. New value will be set to this X. Right? And then you are going to set the RTS of X will be set to TS of T, I, and then you should also set WTS of X will be equal to TS of T. You have to set both. The write TS as well as the read TS should be set to TS of T, the timestamp of the transaction which did the write operation. When you do a write, when you do a read, we are only setting the RTS, that's all. Is set to the largest value of the current read TS. That means you are If you are doing a read, you will set RTS to that particular transaction which did the read operation. So whenever you are trying to do a write operation on the particular data item X, a new version of that is created. So for that new version, you are going to store the value. So we are going to store these three items for that particular version. The value, the new value that you are writing, but you will be retaining the old values also. Multi-versions, multiple versions. And RTA, if you are doing a write operation, you have to set both of them to the timestamp of that particular transaction. Any doubts? What happened? Yeah. Any doubts, anyone? These are all very important concepts, timestamp ordering. You should know it really well. Sometimes we also maintain a log compatibility table. Yeah. So in this log compatibility table, you could have a read log. I mean, you could be doing a read operation, you could be doing a write operation. Similarly, here it looks like a confusion matrix for us, right? Read and a write. So if you are doing a read operation, if is another read operation, is it allowed or not? It is allowed. Yes. If there is a read log, is a write log allowed? No, because write log is always a exclusive log. It is a shared. Read log is always a shared log. Then, when there is a write log, is a read log allowed? No. When there is a write log, is another write log allowed? No. Right? So this is called as a log compatibility table. Okay, and entry S means if the transaction holds the type of lock specified in the column, means if the transaction holds a write lock on X, then no one else can hold any other lock on that. This one. If you are holding a read lock, anybody else also can hold a read lock. If you're holding a write lock on X, then no one can do either a read nor a write. That is what it indicates. Any doubts, anyone?
Ma'am, can you give the difference between ma'am, basic model and this one, ma'am? Multiversion, ma'am?
In basic timestamp ordering, whenever we do a read or a write operation, that value gets updated or rather overwritten. For example, see here. Let us say my value of X is 15. Okay, then I do a write operation on X, write of X I want to do. And then I change, when I do this write operation, let's say transaction T1 does a write operation. When I do this write operation, I will make the value of X as 20. What happens to this 15? It is gone. It is overwritten, right? Now X becomes 20. That's all. Suppose another transaction T2 comes. It does a write operation on X once again. This will make it X as 22. What happens to this X 20? It is gone. Overwritten. Are you getting? So finally, we will maintain only just one value of X. That's all. That is your basic operation. In multi-mode version, what will happen? All the old values of X are retained. You are not overwriting it. You are not losing that data. So what was my data value of X, for example? What was my first data? It was 15. Then second data, it was 20. Third data, it was 22. This data will also be retained. I am not overwriting it. This is my final value, of course. Here also, this is my final value. But here in this case, I have lost that 15 and 20. This doesn't exist only for me. Whereas here, I have maintained that also. Are you getting?
Yes, ma'am.
Yeah. Any other questions, anyone? Anaga?
Yes, ma'am.
Abhilash?
Yes, ma'am.
Akhil?
Yes, ma'am.
Akrut?
Yes, ma'am.
Anusha? Benaka?
He's attending placements, ma'am.
Placement is in the afternoon only, no? Not now, no?
Today morning they're having Oracle assessment test, ma'am.
How many are having?
12 members, ma'am.
Morning Oracle, afternoon you have
Cognizant.
Cognizant. Okay.
Yes, ma'am.
Yeah, I'll check the list in this. Banu?
Yes, ma'am.
Bhargav? Ramtula?
Present, ma'am.
Chaitra? Chandana? Charan?
Yes, ma'am.
Darshan?
Present, ma'am.
Diksha? Dakshayani?
Yes, ma'am.
Kishan?
Present, ma'am.
Harshit? Hema?
Present, ma'am.
Uma? Uma? Jayant?
Present, ma'am.
Divya?
Yes, ma'am.
Kaushik?
Present, ma'am.
Lakshmi? Lavanya? Manish?
Present, ma'am.
Manoj?
Present, ma'am.
Mohit? Naval? Navya?
She's having placement, ma'am, today. Oracle test
I will
match.
check the list. I will check the list. You don't have to tell about others. Panindra?
Ma'am, Panindra is not feeling well.
Absent is absent, not well.
Absent.
Yeah, that's all.
I'm Nikhil, present, ma'am.
Pavan?
Yes, ma'am.
Pooja?
Present, ma'am.
Purnima? Raman? Rashmi?
Present, ma'am.
Rupak?
Yes, ma'am.
Sai Kumar?
Present, ma'am.
Samir?
Present, ma'am.
Santosh?
Present, ma'am.
Chadar?
Present, ma'am.
Sharan?
Present, ma'am.
Shashank? Sheetal?
Present, ma'am.
Shivani? Soumya? Spurti? Vishnu? Sugandhini? Sushma?
Present, ma'am.
Sushmita? Sushmita, you? Tirtha?
Present, ma'am.
Tripti? Harsha, Veena?
Present, ma'am.
Yeah. Thank you all.
Thank you, ma'am.